Hello, everyone. My name is Reza Abdalvan, and I'm the department chair in the Department of Electrical Computer Engineering. And I have with me Justin Phelps, Dr. Phelps, who used to be a graduate student in ECE. He just graduated this past semester. And then I have Zion and Tui, who are undergraduate students in the program. They're going to help me present to you with their stories and why they're at UCF. So let's start with the statement of what UCF mission is. And I just want to add to that that obviously EC as a department is aligned with UCF's mission, but more specifically, my personal promise to all the students in EC is that they're going to be priority number one for the department and myself as the department chair. So let's, for those of you that don't necessarily know what electrical computer engineering is, quickly describe what we are talking about here. So first thing first, I think engineers, if you ask how to define what engineering is, there are different ways to do that, but some people say engineers are problem solvers, which exactly is a correct answer, but this is how I can actually describe engineering. We engineers usually manipulate energy so that it does useful work. Now, if depending on where the domain of energy is, we then designate a different name for the engineer. If the energy is in the domain of mechanical, we call that engineer a mechanical engineer. And then if the energy is in the domain of electromagnetic, that's an electrical or computer engineer. And by the way, electrical engineering is a more comprehensive umbrella over this domain, and computer engineering could be considered as kind of a sub-discipline. But since computers have such an important role to play in our lives, then they actually have their own designation under the larger umbrella of electrical engineering. But there's a lot of overlap between the two disciplines. Now, why do we think electrical and computer engineering is cool and important? For one thing, I found it pretty fascinating that electricity is actually the language of the universe. Whenever the universe wants to talk, it uses electricity or electromagnetic energy. And one obvious answer to why that is that that's the fastest way of doing it. As you know, the fastest thing in the world is a photon, basically light, which is electromagnetic energy. Now, there's a trouble with this domain that we have to get it over with as soon as we start. And the fact that we, electrical and computer engineers, really what we do is to manipulate electrons to move, and then with their movement comes some useful work. Unfortunately, you can't see electrons. And in that sense, there's some problem in getting to know this discipline or kind of having a visual impression of what exactly is going on. But if you ask me, that's actually the beauty of this discipline too. We can consider ourselves as the magicians of the engineers because you can't see what we are working with, which is quite cool and fascinating. Now, these few slides that I'm going to present to you is supposed to convince you that as an electrical and computer engineer, you can make a lot of money. And I promise you that that's the case. I don't think I need to convince you that electrical devices are one of the most prevalent pieces of gadgets that you use throughout your day. I guess the most common one would be a cell phone. You wake up with a cell phone, you go to sleep with a cell phone these days. And obviously a cell phone is an electronic device. And that could be considered as a gadget that we electrical computer engineers design and build. But you go to any other market and you see how electrical devices are penetrating and computers and computation is penetrating into all different facets of our lives. So I don't think it's hard to prove to you that as an electrical computer engineer, you're going to have a lot of options as careers in work, and also you're going to make a lot of money. That said, I don't think you should make a decision based on money. You can quote me on this thing because I think I invented this. If you ask me what is the difference between a job and a career, this is my answer. A job is what you do. A career is who you are. If you ask me to tell you what I'm doing for a job, I say I am a professor. I don't say I do professor. So I suggest that you look into your future with the objective of finding and building a career. And usually when you're trying to do that, you don't just look at how much money you're going to make. This has to be part of your personality, and you have to enjoy what you're doing. More about what kind of jobs are out there. We actually add up all the kind of different jobs that are out there for electrical and computer engineers. This discipline ended up being number one in the number of total employment per year in the past several years. These are just excluding the software jobs that are out there, because a lot of computer engineers, they actually do software engineering, and sometimes software engineering jobs count toward CS jobs, whereas a lot of computer engineers actually end up doing software. If you include that, definitely our discipline would be number one in terms of number of opportunities and employments, both in the past and in foreseeable future. Now, why would you go to UCF to become an electrical computer engineer? So my answer is kind of simple. Location matters. The same thing that they say in real estate and say location, 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 I think is true in universities too. And this is not because we have good weather or we are close to like amusement parks, but it's because when you live in a place that people want to move into and be there, that creates opportunities. And that's what you're going to see at UCF. And I'm going to tell you a little bit more about that just momentarily. But other than that, as I told you, we are really committed to help you be successful in your career, and we can offer you a lot of opportunities. Now, if you just quickly look at this map where you can see UCF right here, you move away from where UCF is just a few miles, and you see a lot of these big name companies that hire predominantly electrical and computer engineers. And this is just in the close vicinity of UCF. And you go further around, I have some data that shows if you put UCF in the center, you go a 50 mile around it in a circle, there are like more than 100 companies that hire electrical computer engineers. And what it means is that not only when you finish, you can actually get hired locally, but also what it means is that during your education, you can get hired by them to do internship, to do co-ops during your fall and spring semester. And there are other opportunities that I'm going to talk to you about momentarily again. A few things more about the academics in our department. We have 50, like most recently, 56 faculty members, which makes us the largest body of faculty in our college. What that means is that there are a lot of research opportunities for you. Each one of these faculty do research in a different area, and if you're interested in doing that, where you can actually see a very short list of what they do, then you have those options. But also what it means is that we can offer smaller courses. We're actually the only department in the college that caps the number of students in our classes to less than 75. Meaning that if there are more students to take the course, we open a new section as opposed to increasing the number, which is going to give you a better access to your instructor and hopefully results in better quality of education. We have different tracks that you can go through, and these tracks are actually growing. And most recently, we actually started a new master's degree in robotics, which is very unique. As far as I know, this is the only master's in robotic degree in the state of Florida. This is what I was going to talk to you about in terms of other opportunities with industry. The domain of electrical computer engineering is so competitive these days that some of these companies are willing to hire you before they hire you. What does that mean? That means that they're going to come give the department funding so that we can hire you on campus. Take one of these companies, let's say AMD. AMD is a computer chip making company. A lot of the computers and computing devices that you use, they use AMD chips today. So they give us funding. We use that funding to choose really good students and then hire them as AMD scholars on our campus. These students during the spring and fall semesters, they work with our faculty that are active in the area of digital system design and VLSI that are aligned well with AMD market. And once the summer comes, the same students get a chance to interview for internship positions at AMD. And then if this relationship between the student and AMD is mutually beneficial and both parties feel that they see a chemistry or a match, by the time that the student finishes, they're going to get an offer, a full employment offer from the company, which is an amazing opportunity for the student because they basically build their career even before they leave school. Now, like I told you, there are a lot of research opportunities in our department. These are just to name a few. Around each one of these areas, we have several labs, both teaching and research labs. I don't know if you've seen any videos of these little dogs, robotic dogs. We have 15 of these dogs in one of our teaching labs and a few in our research labs. And they actually did a synchronized dance in one of the recent UCF football games. Now, how far could you go? Sky is the limit. The alumni of our department, there is no limit in what they can accomplish. This is just a few of the alumni of our department that are in very high managerial positions in multinational companies in Florida and nationally around us. With that, I'm going to stop and let you get to know some of the students of our program. Dr. Phillips, you're up.
Thank you. So I did my bachelor's degree, my master's degree, and most recently my PhD at UCF. And I've gotten to see this school over a long period of time and all the opportunities that it has. My work is in micro electromechanical systems and power electronics. When I was in high school, I was involved in a club at USF, and my friends at USF said, I don't think you should go here. So with that, I was between UF and UCF, but my intention at the time was to work in defense, which is why I chose UCF for the defense relations. So as a sophomore, I got to work at Lockheed Martin through a UCF program called CWEP. I got to earn my clearance and work on F-18 hardware, and I did that for 2 years. And it was fantastic because it worked during my courses. So I was able to take what I learned in my classes and apply it at my work, and take what I learned in my work and apply it in my classes. So it was a really great way to earn money, but also really accelerate my learning. Towards the end of my bachelor's degree, though, I got involved with undergraduate research, and I really fell in love with research, and it convinced me to stick around for my PhD. And a PhDs are an amazing deal. You get paid to learn. PhDs are not something you have to pay for in electrical engineering. These are something that you are paid to do. So your tuition is waived and you're able to work on really cool projects and get paid for it. Right now, I'm an adjunct professor and researcher here, and I'm working on building a power electronics startup company. The thing that really sets UCF apart is all the opportunities. Students who want to do research and students who want to get involved with internships and clubs, they're always able to do it, and it really is a distinguishing factor for UCF. In all my time at UCF as a student, it's never been better than it is right now.
Thank you very much, Justin. We're going to move on to Zion.
What's up, everyone? My name's Zion. Come on, there we go. All right. I will be graduating this spring with my Bachelor's of Science in Electrical Engineering, and my expertise in terms of research is MEMS and RF. Some fun facts about me: I was homeschooled in Ohio. I'm a diesel mechanic by trade. I switched from mechanical engineering to electrical. I was mechanical for 2 years. Justin there brainwashed me into graduate school, so I will be starting my PhD this fall. And I charged the bull for $50. He flipped me like a pancake, but I would do it again. Alrighty, so my UCF story is pretty interesting. I came here in the fall of 22, and right off the bat, I joined a rocketry club. We built a ion thruster, and for those of you who don't know what that is, that's what satellites use to position themselves in different orbital bands. It's like the warp drive on the Millennium Falcon or the Star Trek, the Starship Enterprise, those things. Not as cool, but as close as we can get to that. After that, I became a co-op for the clean room. So I essentially worked as a technician in our engineering clean rooms. I had to wear the bunny suit, did some microfab, great opportunity. After that, I joined Dr. Rez's group, and I am currently fabricating gas discharge tubes. I'm doing PCB design, and I'm also setting up a lot of equipment in our lab for the future. For our senior design project, my team and I are constructing a high altitude balloon, and we plan to hit 100K with that. Now, whether we actually will is to be found out. Hopefully, yeah. And that's about it for me.
Thank you, Zion. We're going to move on to Twee.
Hi. Okay, so I work in the QSIMS MEMS lab. I'm a bit of an oddball because I'm actually an aerospace engineering major. But I'm here to tell you why you should join the electrical engineering department and why this is actually probably a better choice if you are looking to go into like the aerospace industry. So I used to work in a drone imaging lab. And you would think with drones and stuff, right? That's aerospace. You see all like the flight mechanics, and you think I'd be doing all these cool like aerospace related things. But it turns out that there's no aerospace like machine mechanism that doesn't require an electrical system to give it life. So when I was working in this research lab with these drones and things, I got hit with a wall of electrical and I had no clue what I was doing. I freaked out, and then I realized, it might be a good idea to pick up a double major in electrical engineering, because then it will give me a lot more perspective on both sides of the aerospace industry, because you need both some knowledge in like aerospace and mechanical, but then you also need electrical engineering to give the machine life, to get it off the ground, to power it up. And so that's why I've double majored in electrical engineering. So a lot of people will come to UCF and they are interested because we're in a prime location for aerospace. If you're looking to get into aerospace, I would highly recommend doing so as an electrical engineer, because electrical engineering is in such high demand in the aerospace industry, because you get a lot of graduates who know how to do CAD and do mechanical systems, but then they don't know anything about electrical systems. So when they are trying to build and design, there's a big gap of knowledge that's missing. So if you come into the aerospace field as an electrical engineer, you have such an advantage and you're like highly sought after.
Thank you very much, Tui. I couldn't have done a better sale pitch than you did, and I really appreciate you. With that, I'm going to finish with a joke. So if you read the joke and you don't understand it, more reasons for you to join us. Thank you. Hope to see you here in our department.